Hello, everyone. Greetings of the day. Dear authors and invited guests, welcome to Technical Session 10E. Myself, Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th of April 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all our participants to kindly stay connected with us till the closing remarks. And if you have any queries, you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to the chair of our session, Dr. Alpa Ogur. Dr. Ogur is an assistant professor in the Faculty of Engineering at Pamukkale University, Turkey, with approximately 22 years of experience in academic research and tech teaching. He specializes in network and information systems. His research focuses on information security and cryptology, IoT security, authorization models, software design patterns, and advanced algorithms contributing to secure and effective computing systems. So we welcome you to the session. Would you like to say anything before we start our session, sir?
No, thank you. I wish everyone a great session.
Thank you so much, sir. Moving on, I would like to introduce you all to our next chair, Dr. Vishal R. Patil. Dr. Vishal R. Patil is an associate professor, Department of CSE, IT, School of Computational Science, GSPM University, Pune, India. His expertise is in data science, machine learning, blockchain, cloud computing, and support vector machines. His research focuses on artificial intelligence, data analytics, machine learning, blockchain technology, and cloud computing. We welcome you to the session, sir.
Thank you.
Before we start, would you like to say anything to the participants, sir?
No, I think we should start.
Okay, sir. Thank you so much. Now, as per the permission of our chairs, I would like to call upon our first presenter. Our first presenter is Trupti Shirpat Thagre, presenting a paper on the title AI-enabled data-driven modeling and optimization of aircraft climb performance for real-time decision support systems. I request you to kindly take over with your presentation, ma'am.
Thank you, ma'am. Ma'am, I'm not able to share my screen. Yeah.
I have given the permissions, ma'am. Now it will.
Okay. Yeah. Thank you. Is my screen visible?
Yes, ma'am. Your screen is visible to us.
Yeah. Thank you so much. A very good morning to one and all respected panel members, organizers, and my fellow participants. I'm Dr. Trupti Shripat Tagare, and I would like to present my work on AI-enabled data-driven modeling and optimization of aircraft climb performance for real-time decision support systems. This particular work focuses on improving the aircraft climb, making use of the AI techniques, and thereby ensuring the safety of the aircraft, improving the performance, and also the fuel optimization. So these are the contents of my presentation. Pardon? Can I continue?
Yes, ma'am. Continue. There is somebody else's mic. Okay.
Okay. Yeah, thank you. So we will be starting with the motivation for this particular research work, followed by the problem statement, also the physics and the design basis in order to calculate the rate of climb, the AI predictive framework utilized in this work, along with the methodology, results, discussion, and finally conclude with the future scope for this particular research work. So let's move on with the introduction part. The rate of climb is a very vital parameter in the aviation, which is used in order to have a very proper trajectory planning, in order to have the safety of the aircraft, as well as in order to ensure the optimum fuel utilization. So this particular parameter is not just important for the technicians at the ground, but also for the pilots in order to make proper decisions in order to have the safe altitude gain. So there is a lot of advancement seen in the modern aircraft, especially the hardware, that's the engine technology, and also the aerodynamics, where we have the streamlined bodies and the reduced weight of the aircraft, which have helped improve the thrust to weight ratios for the quicker climbs. But the need is for real-time estimation. Whatever traditional techniques have been used would use some static data, that is some pre-tabulated data, and hence the need is for real-time estimation. So we need to have real-time estimation so that we can have a proper dynamic decision making during the flight operations, covering all the variations that the particular aircraft can feel during its climb. So the research objective here is to predict the rate of climb for real flight parameters using AI to enable proactive, optimal climb decisions, thus balancing the performance with sustainability. So as I mentioned, traditionally, there were the sensor-based calculations which were done in order to find the rate of climb, which worked on the static pre-tabulated data and assumed the meteorological conditions. So these methods would fail because we did not consider any dynamic flight environments and real-time variations during that time. Hence, the traditional approaches are having a lot of limitations. Coming to the control models which were used, they also had some prior assumptions of the ideal aircraft performance, and those parameters were taken in order to make the decisions. Again, this would create a gap when we would have the real world uncertainties, variability, and non-ideal conditions. Therefore, this control models would also fail in order to give. Further, the ML models that are present are not going to be giving us real-time data again, because they almost remain offline considering the proof of concepts or retrospective studies. So thus, it becomes difficult to scale them for onboard use. Thus, the research gap identified here is the need for physics-guided, data-driven, real-time ROC predictor that is robust to all kinds of environmental fluctuations and scalable across modern aircraft platforms. Let it be the manned or the unmanned aircrafts, we should be able to provide them with the predicted value of rate of climb. Now coming to the physics and the design basis. So whenever we have an aircraft in the climb phase, it is going to undergo or face four types of forces. The thrust T, which is the forward pull or the required actually the velocity in the forward direction in order to have the rate of climb achieved for our aircraft. The drag is the opposite resistance which is provided by the surrounding environment to our aircraft, which should be as less as possible so that the forward movement and the required rate of climb gets achieved at a quicker rate. Further, we also have the lift, which is in the upward direction, and the weight of the aircraft in the lower direction, the downward direction. That means the weight of the carrier, the weight of the passengers, the weight of the cargo all get added up. That is M into G with the gravitational force pulled downwards. These are going to act on our aircraft. So in order to define what is rate of climb, we can have it defined like the required time in which we are able to achieve the required height or the rate of climb at the fastest speed, that is called as the rate of climb. So ROC, if we have to calculate, it is V infinity into sine theta. V infinity stands for the velocity of true air, that is the true air speed, and sine of theta. So for this, we can consider this diagram. Theta is the angle which is made by our aircraft with the horizontal normal, and this is the direction in which the climb is needed. So ROC is the vertical velocity component which we need to calculate. Now, as I mentioned earlier, that there are these four forces acting, and hence there are force equilibrium conditions which should be met in order to have a proper power balance and find out what is excess power. So how is this excess power calculated? I'll let you know. First, let us understand what is thrust balance and lift balance. So the thrust T should counter off with the drag and the weight. So it's in the horizontal direction, so it's sine of. And L, which is the lift, which has to counter with the weight, and it is in the vertical direction, so it is cos of theta. So the power balance, in order to calculate this, the equation for thrust balance is multiplied by V infinity, which is our true airspeed value, and we get this equation. So V infinity into sine theta stands for the rate of climb. So in order to calculate this difference between T minus D into V infinity becomes our excess power. So more the excess power, more will be the rate of climb. And also we can understand that weight of the aircraft, as I had mentioned, if it increases, then we have to increase our thrust so that we still achieve the required rate of climb. So this is the diagram representing how the four forces act on the aircraft during the climb phase. And this is the block diagram representation of how the flow of events take place. Like first, we are going to give the input flight parameters. The data processing will be done on it. Then we are going to give it to the neural network model, predict the output, and show the same on the dashboard. So input layer, the flight parameters, as I mentioned before, thrust, drag, weight, velocity, and climb angle was given as input. These are the real-time data that we had got from Redome Technologies. This is a startup aerodynamics company that we have in Bangalore, India, and they had given us these data. So with that data, the pre-processing was done, where the data cleaning, normalization, and data splitting was taken place. Then it was given to the ANN model, and further, the output, whatever we have got, is the predicted ROC in units of feet per minute was deployed. It can be deployed for both the ground planning, that is by the technicians, and for the onboard decision support for the pilots in the aircraft. So let me go a little detail into these parts. That is the data set source, as I said, it was from the company. Then the data processing, cleaning was done to remove the invalid entries. Normalization was to have the standardization of the input values for ANN stability. The splitting of the data happened with the percentage of 70, 10, and 20 for the training, validation, and testing. The unit conversions were ensured with the consistency that we have used for the SI units for the given parameters. And this is the model. The sequential multi-layer perceptron was the architecture used with the dense layers, 3 dense layers of 64, 32, and 16 neurons each. The activation was done using ReLU, and the linear output was considered. Regularization of dropout point 1 was considered in order to prevent the overfitting. And the training use was the ADAM optimizer with 100 epochs. So this is the flow of events that would take place. Load the data set, the CSV file we got from the company with the real-time flight data. Convert those, that data was in meters per second. It was converted to feet per minute because we need the ROC in these units. Then select the features and target, split into train sets, normalize the inputs, build the neural network, train the model, predict the ROC on test data, visualize results, and show. So this is the
Excuse me, ma'am.
methodology with the
I'm really sorry to interrupt you. However, we have crossed our 9-minute mark. I request you to kindly conclude as soon as possible, please.
Yes, I'll do it. Yeah. So this is the methodology that was used, which is as I had or as already mentioned. The tools used were Python, TensorFlow, and Keras, Pandas, NumPy for the data manipulation and the visualization on Matplotlib and Seaborn, Jupyter Notebook for the development of the environment. So coming to the results, the R square value was nearly 94%, which means that we are going to have the model captures almost 94% of variance in the climb rate, demonstrating a very strong predictive capability. And even the error margin is very low, which means that whatever predictions are being done are very precise, and thus makes this entire technique very robust. And this is the plot of ROC and time samples where the actual ROC is in blue and the predicted ROC, they are almost overlapping. That's why I have this graph for you where the x-axis is the time period and the y-axis is the rate of climb. We can see that they are almost matching, and hence it shows that this particular method is very precise. The predictions are going to be very correct. Again, on the x-axis, we have the time samples, and the y-axis, we have the altitude. So the actual altitude is in green and the predicted is in purple, which almost overlap, thus making this particular technique and the work appropriate in order to calculate the ROC. So the key findings for this particular work are the thrust and velocity dominance. As I previously said, T has to be very high. The weight has to be reduced. But if at all there is a heavier aircraft, then we should combat it with more thrust value. Even the drag and climb angle play a very important role. So we have to train our ML model accordingly. And the applications and implications here are fuel efficiency optimization is seen because we are able to predict the rate of climb properly. There is proactive decision support, and also this particular technique is scalable. So in conclusion, I would like to say that we have successfully developed a real-time ROC prediction system with a very good prediction accuracy. And the impact is that we are able to have flight safety, fuel efficiency, and trajectory optimization. The future scope will be in order to work on the different environmental parameters like wind shear, turbulence, and air density variations. Also, we can ask the pilot to give the input patterns, and our model should adapt online for it. Also, advanced architectures like LSTM transformers can be used in order to have more better capture temporal dependencies in the flight data. There's a novelty here in this work is combining real-time flight data, a physics-aware parameter selection, and advanced ML techniques in order to build a scalable and interpretable climb prediction model. These are my references for today's presentation. Thank you.
Thank you so much, ma'am. I'll just ask our session chairs, Dr. Patil, Dr. Agbert. So, do we have any questions for ma'am?
Your work is very much interesting. So, did you get the clean data from that company, or you did that, data cleaning part?
No, sir. Actually, we have worked along with the company, as I said. We have worked in their facility itself. So the cleaning part also they have helped us with because we did not have the required algorithms in order to do that. So we had got it from them. We have a MOU with the company, so they have helped, and they are also the authors for this particular paper.
So, you are working on that project in their premises, or have
Pardon,
they
sir?
shared that data with you? They have handed over that data to you?
Yes, sir. They handed over the data to us, but we have worked in their facility only. So now, to show you the data, I was not allowed to take it out of the company.
Because many organizations, they don't allow you to share their data because of
Yeah,
very
they
much
will not share
for
the
their
data.
organization. Okay, so why they have used ANN for that? I just want to know because there are so many, deep neural network. Why they have chosen ANN?
Sir, because it's a startup company, and they said that we will start using these models, whatever are existing, which have given us good results. And under their directions, we were asked to choose this particular algorithm, sir. Of course, there are better algorithms than this, but it has worked well with the given predicted ROC values and whatever they had got prior from the um, for the aircrafts, whatever were already the correct data. So there it was matching, sir. So we went ahead with that.
Are you going to improve this accuracy or you're just going to keep this as it is?
So we are working on the air turbulence, the shear, wind shear, and all on that, and try to even make some different inputs, even if the given value is something else, like we are predicting a value, but maybe there is a sudden change in the environment, or the pilot wants to make some input, then how is it going to affect, and how our model is going to be able to predict. On that we are working, sir.
Okay.
Okay.
Any more questions from our session chairs?
Thank you. You have 0.94 score. That's great. What were the previous scores in literature?
So we had got from the literature survey, the papers had around, sir, 89, 92, like that we had got from who had worked on similar data. There were no much literature papers available with real time. So they had static pre-tabulated data. They were high, sir. Those RMSE values were high, but with considering the real time data, the scores were around 89 and 92, sir.
Okay, thank you.
Yeah, thank you, sir.
Thank you so much, ma'am. Now I would like to call upon our next presenter for this
Yeah.
session.
Thank you. Thank you.
Suhesh Gandhe presenting a paper on the title AI-Driven Automation in Software Engineering, a survey of fine-tuning agentic workflows and vector intelligence. I request you to kindly take over with your presentation, please.
Yes, thank you, Prashi. So hello everyone, good morning. And first of all, thank you for ICTIS, my team members, my professor, my college, and everyone here so that we can begin with our presentation now. So our topic is AI-driven automation in software engineering, a survey of fine-tuning agentic workflows and vector intelligence. Our paper ID is 827. So in our current scenarios, there are many raw and messy client requirements. Into like we have a lot of requirements in from client side in our projects. So that's what we are going to solve in the software engineering part. So that was actually our project. And here our idea originated from a common challenge in software projects where there were unstructured client requirements, and to get it structured and give some knowledge transfer from one project to another, and to give non-technical people some idea over the technical part. That's where our UML diagrams are going to help. So moving forward, I will help you understand more about this. So to solve this, we used an OCR model and a structured technical knowledge base too. And with our prompt generation and using our UML generation model, we were able to get clean and neat UML diagrams. We fine-tuned our own model on a custom prompt to Mermaid UML dataset. Mermaid.js is an open source library where you can create diagrams, and the system automatically generates and renders UML diagrams in real time. So agenda of this project. So first begin with the problem statement. So the problem with manual UML creation is it's very time consuming. The format may change. It has limited tool support and even non-unified pipeline. So here we are trying to solve this, and the manual approach of creating diagrams for any organization, let it be a school organization or a company or anything, any technical aspect, it takes a lot of time. So here we are using a transformer architecture and GPT models. So this is as you can see, we are using a transformer model, and here we rely on the transformer architecture utilizing self-attention mechanism. To train efficiently, we used PEFT, especially LoRa and 4-bit QLoRa, which allows us to fine-tune a model on consumer-grade GPUs while maintaining high performance. Here, as you can see, multi-head self-attention, feed-forward layers, and casual masking using GPT did help us. So talking about PEFT, it injects trainable low-rank matrices into frozen weights, which helps us and reduces the compute a lot. And definitely, as we were training it on an RTX 3060 at our college, so it really helped with 3 epochs. QLoRa could also have been used, but we mainly focused on LoRa. So the dataset construction and training setup. So this was the most important part. We had to we created our own novel dataset from scratch, and where we started with initial basic prompts, like prompt to response pattern in JSON format. And these pairs then we developed further on based on the models. And as you can see, these were the specifications for the training setup, LoRa configuration, and the pairs. And the evaluation metrics were as follows. We then evaluated it on accuracy and F1 score, render success, human ratings from us and other colleagues, and structural similarity. So these were the performances. So we fine-tune each and every model here and use them. And we've got to know that Code Llama 7 billion got the highest accuracy, which is 88.6, while the least being Llama 3 billion model. And these are the F1 scores and render success. The Code Llama 7 billion outperforms every Llama 13 billion actually, because it was domain specific. So what we found was that the coding part done by Code Llama 7 billion was much better than Llama 13 billion because of its domain specific pre-training, which was done earlier. And on that we pre-trained it. On that we trained it. And for our domain specific Mermaid.js context. So this was our end-to-end pipeline for our project actually, which was on getting the requirements, pre-processing it, then structuring it and getting a UML diagram, and then showing it to the users, the project managers, the stakeholders, and everyone. We even use VectorDB, a RAG-based solution, where what it was doing was it was helping us get the knowledge base and even increase the accuracy on uncommon terminology. It was basically a few shot example training like scenario here. So this was the various diagrams which we were generating. This was the accuracy with sequence diagrams giving the highest, and completeness too, with Gantt charts following the flow charts. And these were the human ratings from our colleagues, our professors, and everyone. And sequence diagrams gave the highest accuracy. So this was our solution. Actually, this is another project. And in that project, this is where we did our research and trained our own model for this specific scenario. As you can see, on entering a prompt or even generating a prompt, the model was in the backend. It was giving this response here in the Mermaid.js like format, which was appropriate for a sequence diagram. And as you can see in the right, it was rendering in the Mermaid.js. It is a draw.io actually container here in which Mermaid.js code can be rendered. And this is the diagram. As you can see, it was giving very good results and accurate results. So comparative analysis with traditional models too. So like traditional models as in like traditional ways of creating diagrams and stuff. So we found out that in our scenario, 50 minutes was the time where we took to generate these by hand. And by our model, it took just 3 minutes. And the accuracy may be more, like the manual effort may be 100%, but still the time doesn't matter. And within 33 minutes, we were getting 87% accuracy, where sometimes the actors, the class diagrams, the parameters, the text was getting replaced and getting wrong, but it's okay. This was the OCR success, 94%, and the quality gain. So we were using Grok prompting because we wanted some better accuracy because of manual error while typing or requirements not being clear. So it saved about 45 minutes. So the current limitation, it is some ambiguous requirements and unstated expectations in that requirement document. OCR errors, definitely due to poor handwriting and stuff. Limited data set, it was 2,500 for now because of the costly annotation and mainly the training time also. It was a bit complex initially, but in future, what we are planning to is we are expanding to class diagrams, component diagrams, and state diagrams, even natural language interactive refinement, active learning, like flag uncertain predictions for targeted feedback loop. So where we can mark it as wrong, like a thumbs up and thumbs down, and when we can train it and make it self-learning, cross-domain fine-tuning. So healthcare and financial system, it is what talking about. And multi-document reasoning is where we can even add meeting notes, then even email threads to it to get more context on that topic. So in conclusion, our accuracy on UML generation was 88.6. It took less than 3 minutes, and in manual effort, it was taking 52. The domain was, so the domain does matter instead of size. So that's why Code Llama 7 billion outperformed Llama 13 billion. Full pipeline was like this: OCR, grok prompting, then our fine-tuned model, and the visualization of the diagram. So I would like to thank you, and definitely if you have any questions, you can ask.
Thank you. I have a question. How did you fine-tune to give alternative flows, such as different or better UML sequence diagrams?
So you're asking how did we train?
Fine-tune.
Yeah, how did we fine tune?
Yes. Did you use temperature parameters or just use few shot prompts?
Okay, great question. So we trained it, we fine-tuned it on our data set, and then we varied the temperature and even gave it some few shot examples. But to be specific, while training the model and fine-tuning it, what we faced was that temperature parameter was giving varying results. So what happened was actually the training model part was actually very variable, and the few shot example part gave us better results.
Okay, thank you. And one more question. What type of agent roles did you use on prompts? Have you used any?
Sorry, pardon?
In agentic workflows, have you
Right.
used any agent roles?
Yeah. So for that we used an n8n workflow. In that n8n workflow, we were assigning various agents and using LangChain and LangGraph to orchestrate all of that. So it was all connected in our project, and we were getting responses like various agents, like a manager agent, a coding reviewer agent, a tester agent, and the requirements agent, so that all the diagrams will be connected and have some context to them.
Okay, great.
Any further questions? Okay, seems like it. Thank you so much for your presentation, sir.
Thank you.
Now I would like to call upon our next presenter for this session. Our next presenter is Glenn Eric Zambrano, S2PM, presenting a paper on the title Application of Data Mining to Analyze the Emotional Impact of Virtual Reality on Users. I request you to kindly take over with your presentation. So Glenn, okay.
Hello.
Hello.
Virtual reality becoming an important tool in education because it's creative, interactive, and imaging. learning environments. The object of the study is the understand who virtual reality influence student emotional perception and attitude. Virtual reality al student the interacted with simulate environment. This promotes explored activity parents and with understand of cons. Because of this, university are starts to use the technology more frequent. Eh, the this read used quantitative, descriptive, and res- correlative design. The study included 305 students for the Faculty of Computer Science. Their, their age ranged for 17 to 35 years. The participant of voluntary and all that was conditionally. The experience used the MetaQuest does have said a student interacted with the application called Fair STEM because starting before starting participant receive instructions and the basin was calibrated individuality. The environment was controlled to ensure good condition. Data was collected used a Likert type questionnaire. Its main immersion, reality, attention, emotional, interesting, and entry. This also as the evolution, the emotional experience of the participant. Subsequently, the information was analyzed, also extensive analysis and data main technology both the workflow logic of the scripts design methodology. Descriptive analysis, correct, correlation, metrics, principal component analysis or for dimensionally reduction. Comments clustering to identify emotional profile and association rules. User the a priori algorithm were employed. Uh, priori to conditional, the analysis, the let's see, a data present preparation process was performed. The user the consistency of the information during this stem. The database was reviewed, column name were normalized, and possibility may seem evolution in the response to the linker type questionnaire were clean. Additional variable name and endorsement was constructor, which ended the identifier of emotional change between the moment before and after the virtual reality expression. From the board precision, reality, the, the relationship between the present, the correlative high map for the question items, where modern positive association can be observed between variables shown in immersion and reality, as well as between emotional interaction and empathy. To sensing the database information, principal component analysis was appealed. They show the project of parties onto the first two principal components were concession of point near the original can be observed. Suicide relative homogeneous response parent is the simple. Subsequently, in order the identify possible perfil which respond the command clustering algorithm was approved by Q3 shows how participate or distribute and three distinct groups with the PSK space all the identification of different emotional presence or association with the virtual reality experience. Yeah. The results show a score in immersion, reality, attention, and audiovisual quality. This indicates the student have positive experience use virtual reality principal command analysis explain more than 70% of the data variable. The model present the data where the QMain algorithm identified three different emotional profile one student. A well-month student have a positive experience. Responses were not compatible homogeneous. This main data gen student rate a different the point on factor like experience with technology or emotional sensitivity. This studio showed the virtual reality generation a positive emotional response, high level immersion, raise creative a strong sense of presence. This might the experience well related or emotional ending.
I'm sorry to
YouTube
disturb you, sir. However, we have crossed our 9-minute mark. I request you to kindly wind up soon.
future race. In conclusion, virtual reality has positive emotional impact of a student in increment motive, attention, and engagement. In us control the board technical learning and emotional development. Finally, a virtual reality has strong potential to improve high education. The reference. Thank you.
Thank you so much. Do we have any questions from our session chairs?
Thank you. Did you use any visuals in VR system to create sensor experience?
Hello, good night. The expert student and good wide range of emotion when using virtual reality environment. What possible feelings such as excitement, enjoyment, predominant, and data meaning a technical in fit specific emotional partner, showing that immersive reality virtual scenarios tend to increase motivation and concentration among students.
Okay, great.
Thank you.
Any more questions from our session chairs?
Maybe we will continue. Okay, some network issues, I think. We may continue with Nicholas Schwa Cyber Sentinel paper. An autonomous AI-driven framework. Okay.
Yeah. First of all, good morning to everyone, and thanks for me to giving this opportunity to present my research on this topic, Cyber Sentinel, with my co-authors Dr. N. Revati, Mrs. V. Lada Shivashankari, and Surendra and Abhijit and Sheikh Mohammed. We are from we are from Department of Computer Applications, PG, Hindustan College of Arts and Science, Coimbatore, Tamil Nadu, India. Okay, let me start to get into the research paper. First of all, the Cyber Sentinel is basically an autonomous AI-driven framework for real-time threat hunting and self-healing in Windows-based environments. Why I have made this have a unique reason, which is one second. Yeah, why I have made this having a unique reason because when it comes to an individual system, not all time we are having a security analyst or a security team to check whether the current data are all inside our system is being securely stored, and even if they are checking for and they found any security issues, the time taken to uh, resolve the particular security issue will took a long time if it is done manually. Yeah. So in our Cyber Sentinel, the main focus is to identify the security threats and solve it manually using AI-based solutions, which is in our case the LLM-based and small agentic framework. So the main problem statement here is the cybercrime cost according to annual 2024 annually it was around 10.5 trillion, and the 287 days, which is an average consumption of conception to find a exact security bug in the particular place. In when it comes to small scale and startup based companies, it was taking around 287 days. And even if we find the particular issue, the time taken to resolve the particular issue and being able to resolve it further in the future, it will take about 80 days. This is for only for a small scale and startup middle level companies. When it comes to an individual system, it may even took more time, or it may cannot be even noticed by the particular individual user also. So these are the major challenges we are facing now. So let me tell you how we are solving this problem from our side in our Cyber Sentinel. The Cyber Sentinel is basically detecting all the Windows logs and found the anomalies log, which is like security threats or whatever, which has been detected as an anomaly from the Windows level logs, and it will explain the log based on the LLM, and based on the explanation, it will plan the according task, and it will execute it without any time delay or something. From my context, initially it was detected the Windows logs using a specific model that will come after the next slide. Initially, it will comes from the Windows security logs, and it was detecting the anomalies using a particular algorithm called isolation forest. That was very helpful to detect anomalies or detect um, new things, to detect anomalies and to detect abnormal behaviors in the logs. Why we are choosing isolation forest? Because this doesn't needs any predefined labels for detection, so it can easily detect what are the different abnormal anomalies are there in the Windows logs. Then the detected anomalies will comes to the LLM for explanation. The LLM will explain the anomaly in a user understandable language, so that the user could also read it from the dashboard. And then after the AI explanation completed, then the automated remediate plan will be executed for that particular predefined anomalies, like a failed login attempt or a malicious process detection, like that, this kind of things. Yeah. Then this is the architecture and pipeline of our Cyber Sentinel, which is initially the log collection, as I said before. The log collection has been done using the module Windows logreader.py, which I will get all the logs, current logs from the Windows systems, and then I will pass it to the anomaly detection model. This anomaly model.py uses the isolation forest algorithm to detect the abnormal logs among all the logs. Then it will pass it to the agent explainer, which is in that I have used the LLM, local LLM, Lalama, which will be detect the which will be detect all the which will explain all the detected anomalies from the anomaly detection file. Like for example, log 4632, it is an failed login attempt, so it will explain it properly in a user understandable language. Then the response planner, it will plan a response for the particular anomaly. Like for a failed login attempt multiple times, it will detect the problem, and it will plan a response like kill the particular user ID, something like that. Then the action execution. This uses the Windows commands to execute the actions has been planned by the response planner. And finally, the web dashboard. All these results has been displayed on the web dashboard. Then this I have said before why we have chosen isolation forest. First of all, I will tell how it works. This works based on after collecting all the logs from the Windows log reader. This will randomly isolate all the anomalies, which means it will only get the anomalies that are abnormal based on several features that I have mentioned: the hours of day, user ID, and the event ID. From that anomalies, it will from that all the anomalies it will categorize and get only the abnormal anomalies. So the time complexity to take by this algorithm was very efficient. That is the log of n only. So we have immediately and most fast as fast we can get the anomalies. So we have used this algorithm. We also checked other algorithms time factor, time complexity also. That performs much more, took a very more time than this, like one plus SVM and deep log, then local outlier classifier. Then for that purpose, for the time efficiency, time complexity efficiency, the isolation forest way more outperforms all these algorithms, and also this was much more better to identify the anomalies over a n number of logs. So we have choose this, and then this is the screen that shows AI explanation and automated response, how it works in our Cyber Sentinel. First of all, the LLM prompt input. As I said, the after the logs anomalies have been detected, it will pass them to the LLM. So before send it to the LLM, this is the sample prompt we are giving, which is we will give the event ID, which user, timestamp, and the score, and it all will be passed to the LLM, and the LLM will give a result of what exactly this are this anomaly is. It is in a user understandable language, like user was created at 379 MB and event ID. If it is a failed login attempt, then it will tell something like user has been tried to log in with the event ID something. So this LLM output has been generated using this input. Based on this LLM output, we are we are planning a remediation, which is if it is a suspicious process or something, if any process is very suspicious, then it will kill the process. Like this kind of basic predefined actions that are used to kill the malicious task are running in our system. This is a general one. Then after that,
I'm sorry to disturb you, sir. However, we have crossed our 9-minute mark. I just request you to kindly conclude as soon as possible, please.
yeah, thank you. Then this is the experimental results, which is we got after the Cyber Sentinel. This shows how fast we are giving the response, and how much latency it got for a particular even for a particular for a particular anomaly. It only took around 20 seconds to for a remediation task and execute it. This is a way more good approach, because we have get this with our system specification of only 8 GB RAM, 512 GB SSD, without any GPU. So if any GPU will be there, that will much more efficient for this case. And these are all the sample experimental results we got. Then yeah, these are the automated remediation and safeguards we have using. We have uh, we have we have used many rollback schedules, because accounts, if a account has been failed login, then the account will be disabled or deleted. If a process is malicious, then the process will be killed we are the service manager. If any website has been accessed illegally, then the firewall blocks it. Then like this kind of things are the automated remediation steps we have used. And finally, these are the limitations and future roadmap for our cyber sentinel cell. In the limitations, we have mainly recover admin level privilege to execute the cyber sentinel. Then it is only work on a particular host system. And apart from that, this is only works on Windows for current. In future, we will implement this in multiple OSs. And in the future roadmap, we will implement this in a multiple host based executable system, and it can be adaptable for every type of OSs. And for LLM also, we will try to improve the efficiency of the LLM overall. Then finally, conclusion. These are the things we have used in our Cyber Sentinel project research paper, which is used unsupervised detection, explainable AI, autonomous, the whole part of AI concepts like detection and then explanation and then task scheduling and execution. This all have been done in our Cyber Sentinel. That makes our Cyber Sentinel much more unique. And finally, thank you for presenting me this research paper in the ICTIS conference, and thanks all my co-authors to help me to present this paper and create this the Cyber Sentinel. Thank you. Let me know if there are any questions or anything with that.
Do we have any questions from our session chairs?
Thank you. You use datasets to train isolation first.
No, that is the major advantages of isolation for us, which will automatically took the anomalies from the detected logs, which is why only give what are the logs are suspicious, log IDs are suspicious. It will detect automatically based on the anomalies from the Windows logs. That's why I was specifically used isolation for us.
Okay. Will you use any open source breach and attack simulations like InfectMonkey or AI red teaming tools like Prompt for Future?
I don't use any open source tools for attacking, but I have tried using the local testing method for failed login attempts and creating suspicious anomalies process in my local machine, because testing with open source, I thought that will be a security issue, so that I didn't implemented it.
Okay, thank you.
Thank you so much, sir, for your presentation.
Yeah, thank you.
Thank you. I would like to introduce you all to our next presenter. Our next presenter is Palgula Rangaswamy Reddy, presenting a paper on the title Design and Implementation of a Covert Communication Channel Using TCP IP Header Steganography. I request you to kindly take over with your presentation, please.
Good morning, ma'am. This is Rangaswamy Reddy. I am from India,
Hello, ma'am.
Department of
Hello.
Advanced Computer Science and Engineering, School of Computing
Hello.
Informatics. Ma'am, any problem?
No, sir, please continue.
Okay. Ma'am. My co-authors are Maheshwar Rao, Hariprasad, Akila, and TNVD Sai Krishna. And index, we are going to discuss introduction, literature review, problem statement, motivation, methodology, and result analysis, conclusion, references. In this abstract, this implements a communication channel by embedding hidden data within the TCP headers instead of paying loads. Using the IP identification, the TCP sequence number, acknowledgement numbers, and window size. The sender encodes the data into packets, receiver extract reconstructs it. Data integrity is ensured using the short derivative. Packet loss is monitored. This approach ensures stitch and bypass traditional interaction detection system, highlighting its importance in network research. The design emphasizes the minimal detectability and improves security awareness. This work also provides educational insights into cover channel techniques and their real-world applications. The covert communication is aimed to hide a very extensive of data transport by exploiting unused or less monitored fields of network protocols instead of altering packets, payments, and secret information is embedded within the protocol headers, making detection difficult for conventional monitor systems. In real-world networks, traditional firewalls and introduction detection ideas mainly inspect packet payloads and predefined traffic patterns. In this, the data detects data covertly hidden within the TCP or IP headers fields, allowing unauthorized access exchange to go unnoticed. The rise in cyber spying and data leakage incidents, the covert communication has become a major security concern in modern networks. This project processes a TCP header steganography-based covert channel that embeds secret data into TCP sequence numbers, and it is controlled via a secure HTTP web interface and ensuring steely, reliable, and secure data transmission while bypassing the traditional firewall detection mechanism. The literature review, we have used the methods classification of network covert channels, TCP headers steganography, timing-based covert channels, IP and TCP headers exploitation, and header-based steganography. Our problem statement of existing network security mechanisms rely heavily on payloads in inspection and signature-based detection. However, they often fail to analyze TCP or IP protocols, headers fields, and the bit level, creating a significant security gap. Attackers can access this limitation by emitting sensitive information within legitimate, alternating the payloads, making the detection difficult. So here we are used the example: an attacker encodes the message hello into the TCP sequence by modifying the values across multiple packets. Each packet carries a portion of hidden data while appearing as a normal traffic. Since the payload remains unchanged, the firewall and IDS fail to detect any anomaly, allowing the message to be transferred successfully. In our research and gap on our contribution, the previous studies that prior research in securing data sharing and image protection has largely focused on individual techniques such as encryption, secret sharing, centralized storage systems. While AES ensures confidentiality of Shimer, secret sharing provides threshold-based reconstructions most existing systems. The centralized architecture or incomplete integration of security mechanisms. Furthermore, all two blockchain and decentralized storage solutions like IPBS has been explored. Identically, very limited research combines encryption, secret sharing, decentralized storage, and authentication in undefined frameworks that ensure end-to-end security, scalability, and tamper resistance in image sharing. The motivation: increasing code, cybersecurity attacks, and data exfiltration. Limitations of traditional firewall inspection. Need to understand protocol level security threats. Strong relevance to cybersecurity research. Our main algorithm, the sender side, reads the secret messages from the sender. Appends predefined start and end makers to the message. Convert the message into binary formats, embeds 1 bit of data into LSB of the TCP sequence per packets. Thus transmits the data TCP packets to the receiver. The receiver side starts passive sniffing of income TCP packets, filter packets based on sender IP address, extract the least significant bit from each TCP sequence number, combine extract bits to reconstruct the binary data, detects markers, and recover the original secret message. Or methodology: convert secret message into binary, embeds 1 bit per TCP using the sequence number LSB, transmit legitimate TCP packets, passively captures packets at receiver end, extract bits and reconstructs the message. How our model works: take message or file, converts into binary of zeros and ones, splits into 96-bit chunks, highest bit in TCP or IP headers. Our IP ID, TCP sequence, TCP acknowledgement, and Windows A. Sends packets without payloads. Receiver side, packets extract bits from headers, reorders packets, combine bits original data, verify using SHA-25. Here are our results and analysis. The packets sent are shown here and packets the received. In down we can see the what are the files or PDFs, images, or any messages what we have sent are shown in the send from the sender side, and the receiver side will all receive this files. And we should check that the packets sent or received are properly received or not. Any loss of packets have not to be done. Conclusion. The project successfully demonstrated a covert communication channel by embedding hidden data within TCP IP address fields. The system ensures reliability data transmission with accurate reconstruction at the receiver end. By avoiding payloads manipulation, the communication remains stealthy and bypasses traditional Wi-Fi and IDS detection. However, the approaches has limitations such as low data transmission rate and potential vulnerability to advanced detection techniques. Overall, the work highlights the importance of understanding the code and improving security mechanisms to detect such hidden communication. These are our references. Thank you.
Thank you so much, sir. Do we have any questions from our chairs?
Okay, great work. It's a hot topic in security. I have few questions. What is the message size, the file size you sent on covert channel?
Message size could be very on. It will take some time for the large messages, sir. Based on the package, it will send the messages, sir. For example, in hello, it will be sent in 30 seconds, sir. The increasing of the message size, it will take more time, sir.
Yeah, how many packets you need to use for 100 bits of file or message?
So it will take more than 10,000 packets, sir.
Yes, great. And what about the lost packets in TCP/IP network?
So the lost
How can
packets
you
will
handle
be
that?
So the lost packets will be it will be shown in the receiver side, sir. They will show some of the packets have been lost. So you check properly from your sender side that the packets are sent properly or not.
Yes, and as you know, the same tools search source or destination IP-based anomaly. How can you handle that?
Sir, we should know the receiver side IP addresses so that we can create a code channel. So we have to send through the network, sir, so that it will not we should not send any payloads, sir. So we should send through the only package so that the firewalls or IDS detection could be we can bypass it, sir.
Okay, perfect. And I advise you analyze the entropy of the data you sent. That will be great.
Thank you so much for your presentation, sir.
Thank you, ma'am.
Now I would like to call upon our next presenter for this session. Our next presenter is Bushrat Jahan, presenting a paper on the title Diabetes Prediction for Health Indicators, a Machine Learning Approach. I request you to kindly take over with your presentation, please.
Thank you, ma'am. Is it visible?
Yes, ma'am, your screen is visible.
Thank you. Okay, so hi everyone. I am Bushra Jahan from Minnesota State University, Mankato, USA. And here is my co-authors and my paper ID is 799. So I will walk you through today. This is my research title, Diabetes Prediction from Health Indicators, Machine Learning Approach. So here is the outline. Here we can see why this matters, how we built our model using the LightGBM algorithm, and we can see pretty exciting results. Okay, so we can see here in USA, the report in 2018, 34.3 million people, they are affected in diabetes. And 84 million people in USA, they suffered with pre-diabetes that was found in 2017. And also the International Diabetes Federation, they predicts diabetes will become a leading cause of death by 2030. So why diabetes matters? Because if we don't catch it early, it leads to things like heart disease or a stroke, and many more complex diseases. And also it impacts in our social and economic sector also. So late detection is really harmful for others. So early detection is a key to better outcomes. So here we can see machine learning. So we choose here the machine learning model. So why machine learning is an opportunity? So now we have all this health service data available. So we don't need to clinical or needle or to visit any clinic to start identify who is at risk, right? So we can use patterns in the data to do it in invasively by using the machine learning. So that this is the reason we choose here machine learning model. So our core question was, can we accurately predict diabetes using just non-invasive survey indicators? So as we can see, traditional tests are expensive and hard to get in low resources areas. So we need a smarter and cheaper way. So in our research, we try to find out by using the machine learning model, how can we predict the most important features, how can we predict the diabetes without going to a clinic. So let's see. Here is the objective. So our objective is to develop predict models using machine learning to classify individuals as diabetic or non-diabetic. The second, to identify the most significant indicators of diabetes using feature importance analysis. And finally, to provide insights for healthcare professionals to support early interventions and preventive care strategies. So here is some recent research work. So we can see from here, they use some traditional machine learning algorithm and some gradient boot algorithm. And here we can see from the first research paper, the author used this EHR US patient data set, and they used the KNN and random forest model, and they got 96.09%. And also we can see the rest of the papers, they use the traditional machine learning model, and they find the accuracy like 90%, 91%, 93%, and 86.6%. So our aim is to improve our accuracy by using the large GBM model. So here the existing studies that show they use the ensemble and boosting models, and some use the light GBM that shows a strong performance across multiple studies, and some shows the class imbalance is a recurring but inconsistently handled challenge. So we design a workflow that we followed to find the diabetes prediction. So at first we load the data set from the CDC diabetes health indicators, and then we pre-process our data, and then we clean our data and we analyze our data, and then we split our data as training and testing, and then we use the machine learning model as light GBM, and then we evaluate our model. So here you can see we use the CDC diabetes healthcare indicators data set, and we took 250,000 records, and we classified the whole data set like 0 for non-diabetic and 1 for diabetic. And then we choose the data set includes 21 features which can be grouped like physical health indicators, life cycle, and behavior factors. So here is the data analysis. So in our data analysis part, at first loading the data, and then we inspect the data set, and we remove the duplicate data. So as we can see, after removal the duplicate data, our data set is 229,474. And then we also check the missing values, and then we classify all 20 features in three types. So the types are numerical features, ordinal features, and the categorical features. So here, as we can see, when we train initially in our data, then we found some um, outliers, and then when we found some outliers, then we use SMART technique. As we can, as we know that SMART is the best technique to balance the data for a binary category-based data. So we use the SMART to balance our data set. So as we can see here in figure 4, this is the imbalanced data, and here after applying SMART, we can see the data set is balanced. And then we applied the chi-square test to pick the 10 most features, the highest correlated features. In this table, it shows. And then before going to training the model, we split our data set like 20% for testing and 80% for training. So here, as we can see, the parameters, we use these key parameters here. And then we know there are some kinds of traditional machine learning models, and why we choose light GBM. So as we can see, our data set is a large data set that was included 25 over the 25,000. So we know large GBM is a Microsoft developed model, so it works highly efficient algorithm. It works great for large data set. So there's the reason we use here large GBM algorithm. So let's see the result. So after training dataset with light GBM model, then we got 90% score. And then here we can see we got 10 most important features. And here our confusion matrix, and we can see our RCUC score is 97%. In figure 7, in our confusion matrix, we can see here is a recall is very high, but similarly, as we can see, our ROC and EOC curve score is good enough. So we compared our model with some existing work. They used a light GBM. So here we can see they found only 8 features, and we got 10 features, 10 most correlated features, and also our accuracy is higher than there. And here is the key improvements over the best prior work. We can see that we improved the accuracy, we improved precision, recall, and here we also use the class balancing technique, and we also use the feature selection techniques. So yeah, so at last we can say that our work is good enough for the if we compared with this existing research, then we can definitely say our model works good enough. It improved our ROC score like 97%. And there is also some limitations. The limitations is here we the absence of clinical and genetic variables such as blood glucose levels or genetic data. So our future work to involve more clinically relevant data set, and then we apply more light GBM or a traditional other machine learning model, and we compared. And here is the references. Thank you. Please feel free if you have any questions.
Thank you so much for your presentation. I would like to ask our session chairs if we have any questions for you.
Thank you. As you stated, there are works using light GBM and XGBoost in recent years with 90% accuracy, and you improved them. I want to ask, what do you think, which one make more significant difference? The smooth learning rate or feature selection? Which one improved the result?
Thank you so much. So we found some results without a SMOT. So then we got only um, 80, 88%. But when we applied the SMOT technique, then we got um, 92% accuracy. So I think SMOT worked very well because it balanced our data set. So I definitely say SMOT help our model to improve our accuracy. And chi-square help us um, to pick the most relevant and correlated features.
Okay, thank you.
Thank you.
Thank you so much for your presentation. I would like to call upon our next presenter for the session. Our next presenter is Ruby Bisht, presenting a paper on the title Digital Transformation of Rural Education in India, from the chalkboards to connected classrooms. I request you to kindly take over with your presentation, please. Ma'am? Okay.
One second. Am I visible?
Yes, ma'am, the screen is visible.
Okay. Good morning, everyone. My name is Ruby Bisht from Graphic Era, deemed to be University, Dehradun, India. And my research paper title is The Digital Transformation of Rural Education in India, from Chalkboard to Connected Classrooms. Starting with the background of the study, as a digital transformation is changing how education is delivered worldwide. In India, National Education Policy 2020 strongly promotes the use of technology to improve access, equity, and the quality in the education, especially in the rural areas where traditional systems faces multiple challenges. In the rural areas, the effectiveness of digital education is limited by several infrastructural challenges. Many schools lack the electricity and internet connectivity and access to the digital devices. Additionally, teachers often do not receive adequate training to use the technology effectively in the classroom. These issues contribute to a persistent gap between the rural and the urban education outcomes, making the digital inclusion a critical concern for the education system. For the literature review, existing literature suggests that the digital transformation in education is a multidimensional process involving technological pedagogy and the institutional changes. According to the Bilyalvo et al. And the Mukul 2020 their study, the digital transformation is not limited to the use of digital tools, but also requires restructuring or the curriculum design, teaching strategies, and learning environment to align with the education 4.0. Studies focusing on the rural education in India highlights that the persistent inequalities in the access and the learning outcomes. As per the study of Kingdom 2007 and ACER report 2021, significant disparities between the rural and urban education due to the infrastructural limitation and socio-economical challenges. Research on online learning platforms indicate that the both opportunities and the limitations of this digital transformation. Noted that the platforms like Swayam and Diksha have improved access to the quality education content and enable the self-paced learning. However, the study conducted by Agrawal and the Singh argued that the online education may deepen existing inequalities when infrastructure and digital literacy are inadequate. The objective of this study, as the main objective of this study, is to understand how digital transformation is influencing rural education. It aims to develop a conceptual model that integrates the key elements such as digital infrastructure, teaching practices, and the teacher competitiveness. The study also examines how these components together impact the learning outcomes and the educational access in rural India. The study is grounded in the multiple theoretical perspectives. First theory is constructive learning theory. This theory emphasizes that the learners actively construct their own knowledge through the experience, interaction, and reflection rather than passively receiving information from others. It promotes student learning, student-centered learning, where teachers act as only a facilitators and encourage critical thinking, problem solving, and the collaboration. Second theory is the TAM theory, that is technology acceptance model. This model explains how users come to accept and use the technology. It highlights the two main factors, the perceived usefulness and the perceived ease of use, which influence an individual's attitude towards the using technology and their intention to adopt the same. Next theory is diffusion of innovation theory. This theory explains how new ideas, technologies, and the practices spread within a society over a time. It also categorizes the adopters into the groups such as innovators, early adopters, early majorities, and late majorities and laggards, and emphasizes that the factors influencing adoptions like communication challenge and the societal systems. Last theory is the PPAC framework. This is the technological, pedagogical, and the content knowledge theory. This framework describes the integration of technology, pedagogy, and the subject content in the teaching. It emphasizes that effective teaching with technology requires understanding how these three domains interact to enhance learning outcomes. The conceptual model. This slide presents the core conception model of the study. It shows that the digital transformation is influenced by the main four key factors, that is infrastructure, computerized infrastructure, access to online or the web-based platform. Next is innovative teaching methods. And the last one is teachers' proficiency in the online or the digital modes. And these four elements work together to improve the learning outcomes or improve the better learning results in the system. As for the findings of the study, the digital transformation improves access to quality learning resources in rural areas, online platforms, and the digital classroom enhance the student engagement and participation. Teacher training and digital competition plays a crucial role in affecting the implementation. Lack of infrastructure such as internet, devices, and the electricity remains a main barrier in this, where the digital divide leads to unequal learning opportunities among the students. And technology alone is not sufficient. Proper pedagogy and institutional supports are also essential for the digital transformation. So this comparison shows the shift from the traditional to the digital teaching models, wherein traditional teaching model is teacher-centered. The digital teaching model is the learner-centered, where the main focus is on the learners. The learning materials in the traditional teaching methods are mainly textbooks or the chalkboard, wherein the digital teaching model, multimedia and the videos are playing the main role. In the traditional teaching method, there is a one-way communication or the one-way interaction. But in the digital teaching model, there is the interactive or the interactive and collaborative classrooms. For traditional teaching, the learning speed is all learner informed, but in the digital teaching model, individualized and the self-esteem, it is based on the student. So in traditional teaching methods, the content access is only restricted to the classrooms, but in the digital teaching model, you can access to content anywhere or anytime. Evaluation is, in the traditional teaching method, evaluation is based on ad hoc paper based, but in the digital teaching model, it is ongoing and the data oriented. So, in the traditional teaching method, the role of teacher is only as a transmitter of knowledge. But in digital teaching model, teacher plays the role of a mentor and a facilitator for their students. Same in the traditional teaching method, student role is only a passive learner, but in digital teaching model, the students are playing the role of active learner. In traditional teaching, the learning context is only blended and virtual, but in the digital, this is the scalability. Scalability is limited in the traditional teaching model, and in the digital teaching model, scalability is very high. Conclusion. The digital transformation has a strong potential to improve the rural education by enhancing access, engagement, and learning outcomes. However, access depends on the addressing the challenges such as inadequate infrastructure, digital divide, and the limited teacher readiness. Effective implementation requires a balanced approach that integrates the technology with pedagogy, continuous teacher training, and supportive institutional policies. For the limitation in future scope, digital transformation in rural education faces several limitations, including adequate infrastructure such as poor internet connectivity, lack of device, and the insufficient digital skills of the teacher and students, which contribute to a persistent digital divide. Additionally, the existing research is largely conceptual and lacks studies such as empirical and long-term evidence. However, future research can focus on conducting the empirical and longitudinal studies, integrating advanced technologies like artificial intelligence, strengthening the teacher training programs, and developing inclusive context-specific digital education models to enhance the effectiveness of the digital transformation in rural India. Thank you. Do you have any questions?
Thank you so much, ma'am. Do we have any questions for ma'am? I'll ask the session chairs. Dr. Alper and Dr. Patil, do we have any questions?
I am curious and I want to ask, you stated students become active learners in the system, and what do you think how students' prior experience on these platforms or classroom might affect the results?
Sorry, can you repeat your question?
Okay. You stated teachers' experience on these systems affect the results, and I'm curious how students' prior experience might affect the results.
Did you get the question, ma'am? Hello?
Hello.
Yes, ma'am. Did you get the question?
Both teacher experience and the students' prior experience influence the outcomes of the digital environment. As for the students' experience with technology, also plays an important role because students who are familiar with the digital tools are more quickly adapt and participate in the learning environment. So I think this can affect the process.
Okay, thank you.
Thank you so much. I request you to kindly stay, ma'am, as the next paper is also presented by you. I would just announce the title of the next paper. Our next paper again is presented by Ruby Vish, presenting a paper titled ICT for Sustainable Development, Enhancing Teachers' Work-Life Balance and Job Satisfaction. Ma'am, I request you to kindly take over.
Okay, thank you, ma'am. As for the background of the study, ICT is significantly transforming the education by introducing digital tools such as learning management systems.
I'm sorry to
Sorry, there is
interrupt,
no
ma'am.
presentation.
The presentation is not here right now.
Okay.
We're still at the thank you slide of the last presentation.
Okay, ma'am, 1 second. Ma'am, is my screen visible?
Not yet, ma'am. Yeah, now we have 1 second. It's loading.
Okay. Okay.
Yes, it's here.
Okay. As for the background of the study, ICT has transformed the education by introducing digital tools such as digital classrooms and the learning management system with the online learning. It enhances the flexibility, accessibility, and innovation in teaching practices. Moreover, ICT plays a vital role in achieving SDGs goals. Like for the Sustainable Development Goal 4 is related to the quality education. Sustainable Development Goal 3 is the well-being of all, and the SDG 8 is with the decent work conditions. So the coming with the problem statement, it has transformed, ICT has transformed teaching practices, but it has also led to the challenges such as workload or 24 into 7 digital connectivity. This has blurred the boundaries between the personal life and the professional life, leading to the stress, burnout, and the reduced job satisfaction. Despite the growing importance of ICT, there is a limited understanding of how it affects the work-life balance and the job satisfaction in the educational settings and highlights the need of the further study. The existing literature suggests that the ICT plays a significant role in transforming education by improving the accessibility, flexibility, and the teacher efficiency. But research by Selvin and the Redeker highlights that the ICT enhances instructional practices and support the digital learning environment. However, studies suggested by Dirks and the Lewang indicate that the increased digital connectivity can lead to work-life interference and the technology stress, which can negatively affect the teacher's work-life balance. Further, the studies by Greenhurst and the Skalvik results in the stress, burnout, and the reduced policies and the clinics can enhance the autonomy, efficiency, and the job satisfaction. For the objective of the study, the objective of the study are to examine the role of ICT in the education system, to analyze how they impact the teacher's work-life balance and the relationship between work-life balance and job satisfaction, to link the ICT with the sustainable development outcomes. The theoretical framework of the study is based on the JDR model, which is job demands and resource model, which explains how workplace factors influence the employee well-being and the performance. It also classifies the job characteristics into the job demands and job resources. Job demands are the aspects of a job that requires efforts and may cause stress, such as workload, time pressures, and the continuous ICT connectivity. Whereas the job resources are the supporting factors that help in achieving workforce, reducing the stress, and enhancing motivation, such as autonomy, organizational support, and the access to technology. In the context of ICT in education, technology can act both as a demand, which can increase workload and the technician, and the resource, that means improves the efficiency and the flexibility. The balance between the demand and the resources influence the teacher's work-life balance and the job satisfaction. The conceptual framework is that ICT influences the workload, flexibility, and digital connectivity, which then impacts the work-life balance of the teacher. And the work-life balance plays the role of a mediator, and that leads to the outcome such as job satisfaction. So work-life balance mediates the relationship between the ICT use and its impact on the job satisfaction. This relationship can further moderated by the institutional support, policies, or the teacher's competitiveness. For the positive impacts of the ICT, it enhances the teaching flexibility, also improves the access to digital resources, supports the innovative pedagogy, reduces the administrative burden, or increases the professional autonomy. Then for the negative impacts, it increases workload and the time pressure, digital load and the technical, constant availability expectations means if you are using ICT, you are expected to connect it 24 into 7 work, which can impact the teachers' work-life balance and also work-family conflicts and reduces their personal well-being. The linkage with the SDGs is that SDG 4 is related to quality education, means improved access on the learning quality, and for the SDG 3, well-being means teacher mental health and balance can also be influenced by the ICT, and SDG 8 is related to decent work, means it is related to the better working conditions. The study concludes that the ICT plays a dual role in education, acting both as a resource that enhances the flexibility, efficiency, and teaching effectiveness, and demands that increase the workload and stress. Work-life balance emerges as a crucial factor influencing the teacher's job satisfaction and the overall well-being, where effective and balanced use of ICT supported by the proper policies, trainings, and the institutional support is essential for achieving sustainable and the satisfactory work environment in the education. For the limitation and the future scope, the study is only limited by its conceptual nature and lack of empirical validation, which restricts the generalizability of the findings across the different educational contexts. It also does not fully capture the variation in the ICT access, institutional support, and individual difference among teachers. So, future research can focus on empirical and longitudinal studies to examine the long-term impact of ICT on the work-life balance and job satisfaction, exploring the moderating factors such as organizational support, digital competitiveness, and investigate the role of emerging technologies like AI in enhancing sustainable and teacher-friendly education environment. Thank you so much.
Thank you so much, ma'am, for your presentation. Do we have any questions from our session chairs? All right. So, as we don't have any questions, thank you so much for your presentation, ma'am. I would
Thank you.
like to call upon our next presenter for this session. Our next presenter is Vasumati R, presenting a paper on the title Predicting Future Communication Skill Demand in Higher Education Using LSTM, a Temporal Forecasting Framework for Employability Analysis. I request you to kindly take over with your presentation, please.
Yes, and session. Are you able to see my screen?
Yes, ma'am.
Okay. Good morning, everyone. I'm presenting LSTM CDSF Predicting Future Communication Skill Demand in Higher Education using LSTM. This work proposes a temporal deep learning framework to forecast communication skill gaps and improve the employability outcomes. And coming to the problem statement, India faces a major employability gap. Only about 55% of the graduates are employable, and 73% recruiters report that there are students are lagging in the communication skills. Meanwhile, the demand for skilled workforce is rapidly increasing, and in the near future there are a lot of openings are coming up to 1.27 million. That is why we are more keen on focusing on communication, which is a core employability skill across all the domains, and we don't want to take this paper with the domain specific this thing. And coming to the research gaps, we did conduct a thorough literature survey among 25 papers, and we found that there is no integrated framework comprising of assessment, prediction, and taking them into action. That is the first thing. And second thing is it's a point in time assessment. When it been point in time assessment, they have used only static data, not time based progression, because when skill gap has to be calculated, the skills needs to be periodically updated, right? So there is no point in time assessment pattern used in the past papers, and also it uses only aggregated skill course and not the actual skill gap, which needs the curriculum interventions. So our work addresses all these three using the temporal modeling. And coming to the methodology, data set design and justification, we have used synthetic data due to institutional privacy, because real student records cannot be shared from institutions because data privacy issues are there. And if we use synthetic data, it is easily reproducible because we have fixed the random seed to 42, and so that any researcher can regenerate the exact data set. So we wanted to have a fully reproducible environment and the calibrated realism, because the parameters what we used in our synthetic data is parameters drawn from the NASCOM report 2024, India Skills Report 2024, and Deloitte projections. It's not the random values what we have assigned. And coming to the data set configuration, we have just tried with 240 students across a span of 18 months, that is from August 2021 to Jan 2023, and we have used 6 skill dimensions. Okay, like, LSRW, digital, intercultural, and, all these things. And we set the score range to 0 to 100, and the baseline industry demand is between 67 to 76.1. And as you said, random seed is 42, which is again reproducible. And coming to the pre-processing, it is a four-step window. We have used a min-max normalization, and each skill score is scaled to 0 to 1 scale, so that it is independent per each skill dimension, and it is applied separately to train the and test splits to prevent the data leakage. And sliding window is used for the 6 months input on a 3 months prediction. And train test stratified split is 80-20 split stratified across the student index and 480 sequences, and no student appears in both the splits. So duplication of data is not there. And validation holdout is 20% of the training set held out as validation and used only for the convergence modeling and never for hyperparameter selection. So total sequences generated by us is 2400. The reason we use sliding model is, it can learn only temporal patterns and the trends. And coming to the model architecture, we used stacked LSTM, layer 1 with 64 units and with a dropout of 0.2, and layer 2 with 32 units, and the output is, the 6 skills. The reason we used is to layer, to prevent the overfitting and to memorize the synthetic data patterns. And again, let's go on to the training process and convergence. The model is trained using the Adam optimizers. And if you can see the metrics, how the model was trained, validated, and confirmed stable, data loading is 1,920 training sequences are already loaded. And 20% of the training data is withheld for the validation loss monitoring, so that, the overfitting epoch by epoch is avoided. And we have used the forward pass with 32 sequences fed through the LSTM layer 1, dropout, and then the layer 2. So all the 6 predicted skill cores per sequence are generated, and loss computation between the 6-dimensional vector between the present and the future, is the MSE across both the layers is updated using the Adam. And if you see at the screen, the MSE epoch 1 is 21.0, and train MSE in the 50th epoch is 3.8, and during validation it is 3.8. So it clearly shows that during training there is no overfit, and the convergence pattern is also steady. There is no oscillation. So here, this is how we confirm that the model is generalized, seen unseen sequences, and taken it forward. And coming to the testing protocol and the baseline comparison, we have tested on 480 unseen sequences compared with, the other models on how it works. Because since we have chosen LSTM, we just wanted to check how the NAV, linear regression, and ARIMA, how it performs. So these models, we found that these models cannot capture the non-linearity or the multi-skill interactions. It has been trained with only, one particular input for one particular institution. So we just chose LSTM because of this. Because ARIMA and other things, they're all standard time series based. So we are not able to compare those with our model. And these are the results. And LSTM CDSF performs really best. If you look at the results, our MAE is 1.468 and RME is 1.8, and MAPE is 2.61, and our R2 is within the range of 0.9249. So there is an improvement amongst all the models. Our model is 60% better than the linear regression and 55% better than the ARIMA. So it shows that the deep learning is more effective. Is this a comparative chart? And for the skill gap analysis, where the deficits are, because I said these are the skill parameters which we measure our students across, right? So we are using this formula. The gap is industry demand minus the predicted skill. So we found that, the high gaps are found in digital communication and intercultural. So moderate gaps in writing and presentation. So these are the basically to understand the high intervention levels, because it leads to the actionable curriculum decisions on, where the students need to be trained upon and improved upon. And residual analysis and student growth profiles for each of the 480 test sequences across the 6 skills. We computed, actual score minus the predicted score. So residuals are symmetrically distributed around 0, which means no systematic under prediction is there. So across all the 6 dimensions, we found that there is no drift as shown above. And coming to the discussions, we found that skill gaps are systematic. LSTM captures all the non-linear growth, and LSTM beats all the statistics because of non-linearity. Because ARIMA, when we try, it assumes stationarity, and student skill growth is non-linear. whereas our LSTM captured growth plateaus, acceleration, burst, and all the cross-skill accelerations. And R2 and variance is also intact. And we just tried with the 3 months horizon, and it is actionable because a semester period in India is 6 months, right? So 1 month will go on exam, and 4 to 5 months, students will be available to take up all the skilling. So 3 months forecast will give the training and placement department enough time to deploy targeted workshops before next placement cycle. So coming to the limitations, we just tried with synthetic data pertaining to just one college. Maybe we have to have more number of 2 tier 3 tier rural institutions, different demographics, and more technical colleges. And time window has to be increased. And the correlation also we have to see how the attention mechanism works. And since it's very simple minimal data we didn't try with GRU transformer and things like that. Maybe we have to test those also. And coming to the implementations, it has a direct implications on SDG 4 quality education and SDG 8, which talks about the employment, because we focus on early skill gap identification, early identification, and monthly forecasting, and giving the educational institutions to action on their curriculum, because they have to prioritize the skilling part and deploy monthly LSTM to forecast to the training and placement offices and identify the progressive learners and align their curriculum catering to the industry and all those things. So we wanted to build a system framework which combines all these things rather than reactive after the failure. We want the institutions to be more proactive. And what makes our research novel is, the first, we found that we are the first end-to-end integrated framework for the Indian education system, as he said, which captures the assessment, temporal forecasting, and automated curriculum decision support, and, tragedy-aware assessment for the temporal shift, and per skill gap quantification with the actionized threshold, so that, based on the reports from different job boards and like NASCOM things, industry benchmarks can be captured, and interventions are signaled to the or institutions or universities aligning to the NEP 2020 training and placement officers workflows. And these are the reference papers what we refer. And I strongly say that this model enables accurate prediction and early intervention and better employability system. Thank you so much for ICTIS for giving me this opportunity. Open for any questions now. Thank you.
Thank you. You have 6 skills. They might be interrelated. What do you think? How cross skills or interrelated skills affect the overall result?
Yes, if there are 6 skills because in educational institution in India, how we work, we will have employability assessments pattern when a student joins the university, assess their skills, and do a categorical biasing based on ABC, based on their skill level, okay, and map the students to the respective workshops based on their skill and where they fail. Now, after Gen AI, the industry is totally shifted, and the level of demand is gradually increasing. And if a student, for example, if fails in all these things, more and more of intensive exclusive training is required for him. Either it can be a value added, or it can be a curriculum revision at the university level. So all these key skills are very, very important. I, being a dean training and placements, every day interacting with the industry, we are getting all the requirements from the industry and also from the different job boards, as I mentioned, and it will definitely help, I feel.
Thank you.
Okay, thank you.
Thank you so much for the presentation. Now I would
Thank
like
you.
to call upon our next presenter. Our final presenter for this session is VNVR Karthik, presenting a paper on the title Specialized Low Power ASIC Architecture for Computing Eigenvalues in Two-Dimensional Linear Transformations. I request you to kindly take over with your presentations, please.
Hello, good morning, ma'am. And
Yes,
my name is VNVR Karthik, and I am from Electronics and Communication Engineering from SR Goodlall Engineering College, India. And Today, I'm presenting the research paper on behalf of my team, which is specialized low power ASIC architecture for computing eigenvalues in 2D linear transformations. And the main thing here is the computation in hardware makes the cost very much high. The presentation outline here is, let me go to the presentation outline. And this is what the quick roadmap of what we will cover in next 10 minutes, starting from the problem, moving through our proposed solutions and results, and closing with applications and conclusions. Let's get into the actual problem statements. And what actually we prefer to make this problem is eigenvalue decomposition is fundamentally DSP, robotics, and embedded analytics. And conventional software implementation impose unacceptable latency and energy overhead. That means eigenvalue computation is heart of many real-world systems, digital signal processing. The challenge is conventional software implementations of eigenvalue solvers are slow and power hungry. Main thing is power hungry and slow. And they rely on iterative and numerical methods like Jacobian QR decomposition, which is computationally expensive to the hardware. For battery powered, always on embedded systems, if we take an example, think wearables, IoT nodes, or edge AI. This is simply unacceptable. The sub millivolt range is somewhat more power hungry in the scale of embedded systems like smartwatches, etc. So we aim for the microwatt range. And the next thing we have to see is literature review of this. Looking at the prior work and what we are seeing in this table right now, the field has largely focused on iterative solvers mapped onto FPGAs or general purpose ASICs. Yang et al., the first one in this table, proposed ASIC using Jacobian algebraic approach. But the main thing here is it has a larger silicon footprint. And the next one is also having the same. The thing is 2.5 milliwatt, even though it has a low power, but in the edge embedded low power embedded devices, it may be considerable as somewhat high power. And the next one is the Alvin Berger from 2020. He's using the FPGAs 2 and Spartan 7. So everyone maximum uses the FPGAs for their analysis and researches. So we want to make a dedicated ASIC for the operation of determining eigenvalues. The next one is the critical gap across the work in this. None of them exploit the closed form algebraic solution exclusive to 2 by 2 matrices, which eliminates iterations entirely and embraces far more compact and efficient hardware realization. And if we go to the next slide, abstract, what we have to do. In summary, our contribution is a dedicated ASIC that computes eigenvalues of 2 by 2 real integer matrices using a direct algebraic, no iteration, no approximations. We implement it in the RTL Verilog and synthesize it in Cadence Genus in a standard 180 nm CMOS technology. And the results are compelling that a total power of just 0.5738 millivolts, or in other words, 573.8 microwatts, and a silicon area of just 1703 square micrometers square. And I'm again 1703 square micrometers square using just 196 standard cells. The dynamic to static power ratio is amazingly we got to 98.66, which is far more efficient than the existing ASICs on this topic. It represents the minimal leakage of the power. And if you go to the proposed architecture, what we have done for this type of advanced optimization, we followed a specific algorithm. We represented algorithm using this flowchart. We developed using the Raptor software. And the next thing, like walk through the architecture. Our design is 5-stage data path controlled by a compact 5-stage finite state machine. You see this on the screen right now. State 1, which is idle state, initialize all internal resistors, matrices, and etc. And the second stage is check state, which is acknowledgement for handshaking signals. The transitions from the one state to another takes place, and the capture state is the state which takes the input from the external signals, and the sequential latching ensures the arithmetic core receives stable, glitch-free, and inputs before any computation begins. And after taking all the calculation, all the inputs, the next stage is probably the calculation case. The arithmetic core computes the trace as plus d, the determinant as d, and minus b, c, and then evaluates the discriminant as trace squared minus 4 times the determinant, which is the calculation formula for the determine the eigenvalues of 2 by 2 matrices. And we can see the formula in the general eigenvalue calculations. And the last stage is output stage. Based on the discriminant sign, and I'm repeating that, based on the discriminant sign, if negative, a complex error flag is raised. If not negative, the square root of the discriminant is computed using a non-restored digit reference algorithm. And the two eigenvalues are resolved via the quadratic formula. The success flag is raised. And the main thing uh, the main thing we got through this efficient algorithm is the result we shown here are and I want to mention other things that the y-axis is on the log scale because the log scale shows the large range of values on the same graph. So we preferred over so many things. And you can see that the 0.573 total milliwatt is the total power consumption. And the picojoule, 28.69 picojoule is the energy for computing this single eigenvalue pair. And these are the statistics we have. And the main thing is how we reduce the power that much. The main thing is how you reduce the power that much. You reduce the power by decreasing the multiplier and division circuits by using just shift registers. A multiplier to a shift register is like comparing to a large bus to a small car. That much efficient algorithms and hardware efficiency is maintained by using while developing this ASIC. That means simple 2 by 2 multiplication is made using a shift registers. Division is made using a shift register by D flip-flops. Only 4 D flip-flops are used to make this operation. This is actually 80% compression in the multiplier circuits. And the power analysis is 98.66% and 1.34% is static power, which is the leakage power, which we also call. This is the very efficient power consumption ASIC. As we see that in the graphs, the results are very compelling. And the next one is we see the power consumption by each component, registers, clock, and logic. The logic consumes the 59.35%, which is the main thing for us. And registers and clock. Clock is also consuming very less power because it runs every second in the chip, so it has to consume less power. Otherwise, the clock should have to be highest power consuming components. We have a dedicated clock component in our IC. And the last one, comparing existing works, our work is 180 nm, and if you see that our work is highlighted in the vertical column or first column, and everything you see is the very high efficient low power and high performance architecture for the ultra low power. And if we compare it to the others, 180 nanometer technology is our available technology in our Cadence. And Cadence Genus is the synthesis tool, and from the synthesis netlist, we move on to the Cadence Innovus, where the physical design begins, and the ASIC architecture, the backend begins in the Cadence Innovus, which is where we made the pre-clock tree synthesis and timing analysis, etc. And the last one we have to go is the applications. Applications we see eigenvalues are in for the general purpose satellites, drones, etc. Eigenvalues determine the stability of a system. Stability means the eigenvalues considered in a 2D plane, the vectors which don't rotate but scale in the 2D plane. Whenever we apply a curl to a vector using a matrices, the vectors rotate in a plane, but some of the vectors don't rotate, but they scale only in the 2D plane. Those vectors are determine the stability. They are called the eigenvalue vectors. And these applications and medical wearables, wireless sensors, and embedded vision. We see that communication in the everything we use here for the stability of any control systems. And let me conclude the session using the statistics what we obtained. The power is 573 microwatt and the area is 1700 micrometer square and the latency is 50 nanoseconds approximately. And dynamic to static power ratio is 0.98, which is a low power, ultra low power power usage. This is the first dedicated ASIC for the closed 2 by 2 eigenvalue solution in silicon achieve sub-milliwatt powers. And the latency is deterministic. That means the every output is deterministic and calculated using the worst case scenarios and best case scenarios of PVTs like FFT, etc. And fast TT in the Cadence Innovus environment. And these are the references, and let me conclude the session and thank you for giving me this opportunity, and I'm very great to take this presentation. Welcome to the queries.
Thank you so much, sir. Do we have any questions from our session chairs?
Yes, a simple one. You mentioned the advantages and use areas. What are the downsides of the model? Number of components or implementation hardness? What do you think?
Yeah. Yes. May I know that are you asking about the some of the lacking features?
Yes, yes.
Yeah, main thing here is the actual as in the first work in this domain, we are actually done for 2 by 2 matrices, and in the future scope, we are going to make it in a larger matrices for this larger system stability. Uh, Up to now, we are having 2 by 2 matrix ASIC, and after that, the larger systems which are having the parameters of 5, 10, and etc. Some number of parameters, we are also going to develop the same type of ASIC for the larger systems. This is the main drawback and down of this system.
Great work. Thank you.
Yeah, thank you, sir.
Thank you so much. With this, we come to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 11th version and all the previous 10 versions of this conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. I would also like to thank our session chair, Dr. Alper and Dr. Patil. There's a small token of appreciation from a team of ICTIS. Before we conclude, sir, do we have any final words or remarks from your end?
No, thank you for your dedication, Prashi.
Thank you so much for your presence, sir. Thank you so much, Dr. Patil, as well. Thank you so much for being a part of our session. I just request all of our participants and the presenters to kindly switch on to your cameras for a quick final snapshot of this virtual meeting that we just attended. Requesting all our participants to kindly switch on to your cameras for a quick snapshot of this virtual session that we just attended. Kindly switch on to your cameras, please. Thank you so much. Stay safe and have a great year ahead. We'll see you in next year, 2027, for the same session. Thank you so much. Thank you.